With the majority of Florida's water supply originating from underground sources or aquifers, it is extremely important for agricultural operations to protect these aquifers from contamination. Successful wellhead protection includes complying with regulatory requirements and using common sense measures with regard to well placement and agricultural practices near wells. Safe use of chemicals such as fertilizer and pesticides around wells is essential and can be divided into mechanical and chemical categories. Mechanical components include devices for preventing chemical backflow into the well and thus contaminating groundwater. Chemical safety includes measures such as following manufacturer's guidelines. The functions of the safety equipment components are to prevent contamination of ground and surface water by applied chemicals. The devices incorporate ways of minimizing spills and operator hazards. The list on the screen provides the commonly required devices, their purposes, and their location. Any irrigation system designed or used for the application of chemicals shall be operated with the following components. Backflow prevention. Current Florida law requires that backflow prevention equipment be installed and maintained on irrigation systems which chemicals are injected for agricultural purposes. An anti-siphon device such as the one in this photograph is a safety measure used to prevent backflow of a mixture of water and chemical into the water supply. Check valves. A functional check valve located in the irrigation supply line between the irrigation pump and the point of injection of a chemical is required. The check valve will prevent water from flowing from a high elevation or pressure in the irrigation system back to the well or surface water supply. It will also prevent water from being siphoned back to the water source. Thus, water with chemicals cannot flow back into the water supply. Drains and vacuum breakers. Drains and vacuum breakers with an orifice size of at least 3/4 inch in diameter is required. State law requires low-pressure drains to be located on the bottom of the horizontal pipe between check valve and the water source. It must be located so that the water flow does not drain back to the water source. A vacuum breaker should be installed on the top of the horizontal pipe between the check valve and the irrigation pump and opposite the low-pressure drain. The vacuum breaker will allow air to enter the pipe when pumping has stopped so that water flowing back to the pump will not create a suction, drawing additional water and chemical from the irrigation system to it. The vacuum breaker must be located upright and above the irrigation pipe so that it functions effectively. Chemical check valves. A functioning check valve on the chemical injection line is also required. If injection pumps are used, they need to be installed so that when water stops, the injector pumps will not operate. When the chemical injection pump is electrically driven, its electrical circuit must be interconnected with the irrigation pump's electrical circuit to assure that it stops when the irrigation pump stops. If the irrigation pump is mechanically driven from a drive belt with an engine-driven pump or by water flow in the irrigation system, the power supply interconnection is not needed. In these cases, when the engine stops, the injection pump will also stop. Chemical storage tanks must be located in an area that is remote from the well site or surface water supply. Tanks should also be sloped so that contamination of the water supply will not occur in the case of tank rupture or spillage. The chemical supply tank should be constructed of materials that will withstand the corrosive chemicals stored in it. Some chemicals and tank materials are subject to degradation by sunlight. Therefore, chemical tanks are often painted to exclude sunlight. State law requires chemical tanks to be placed in containment structures if hazardous chemicals such as pesticides are stored. Containment can be achieved by construction of watertight concrete pad with concrete block walls sufficiently large to hold 1.5 times the capacity of the chemical tank in the event of tank failure. Polyethylene soil liners can be used under the tank in permeable soil areas or where toxic chemicals are being used.